So good afternoon. It's 8 p.m. in Ljubljana, Slovenia. I'm still drinking coffee, so yeah. The main thing, the link here, everything is on my GitHub repository, so just follow that and you should be fine. Okay, so I'm just gonna blaze through a couple of slides just to give you some common ground for those who are not familiar with Azure Databricks. And since then we'll just dive into a couple of new stuff and analytics and what you basically can do with that. So for those who are not familiar with Databricks, it's a collaborative platform. It's agnostic, but in this case, it's applied for Microsoft Azure Cloud. It is Apache Spark. Everything is written in Apache Spark, actually. So it's fairly straightforward setup. You can do, many collaborative workspaces. It supports native integration with Active Directory, Power BI, all the services, stuff like that, and makes it fairly and extremely easy. In terms of all the compliances and SLAs, everything is enterprise grade. You don't really worry about invoicing because you get billed once instead of multiple times. So it is a service, standalone service on top of Microsoft Azure, and it is beautifully integrated in the cloud. So it has been around, circling in Microsoft Azure Cloud for a couple of years now, and in the past COVID, so before COVID, things were doing great, but in this COVID era or after COVID, there has been fairly beautiful upgrades worth mentioning, especially if you're coming from this data platform side, meaning that you are either data engineer or data scientist or SQL guy. We'll touch base today with all those stuff. So what has brought in the past year, it's separation of those workspaces, which I'll cover that later. Much better data orchestration for those who are data engineers. SQL, Databricks on SQL for those who are in love with SQL language. And also Delta Lake has had quite a few upgrades since the second version. So quite a lot of new topics and new stuff. Just, some promo material. So what is Databricks? It is a collaborative workspace. It supports deployment, production workflows. It has optimized runtime engine, and it actually outputs or supports any type of data ingestion and scale without limit, push the data to end points such as either any type of visualization tools, data warehouses, machine learning stuff. So it's, platform as it is. So what are the latest new concepts? The latest new concepts are Delta Lake for data orchestration, and this is something we'll just cover it today. MLflow and Koalas, data science workspace, the great collaboration with notebooks and version control, and also Databricks SQL built on top of Lake Lakehouse architecture. We'll also just briefly touch what Lakehouse architecture is. So I'm just going to go straight to the concept. So what is Delta Lake? Delta Lake is a open source software that was adopted in Databricks. It supports actually any type of ACID operation between different storage areas, layers, or zones, whatever you want to call them. So you're in you're in cloud and you want to have your data storage separated based on type of hot or cold path, so being streaming or batch, and then you put your data in ingestion table or zone or row zone, whatever you want to call it, and then you do something with data, you aggregate the data, and then you add some additional let's say dimension, data, information, stuff like that. So all these ETL type of data preparation, data aggregation, and data serving is done using Delta Lake, and it supports ACID operations. So for those who are working with those stuff like Apache Hudi, Iceberg, Delta Lake, you know that sometimes this keeping all those ACID operations, all those operations in ACID form, it can be hard. Everything is fully supported with Apache Spark APIs, and you can basically read or do any of those stuff basically anywhere from the notebooks. You can also read and write those data directly from SQL database, Databricks SQL. So it basically has all those needs that you want to do. For data scientists, MLflow is, again, an open source software that was sort of silently introduced in Databricks a couple of years ago, and nowadays it hiatus in terms of it is much better integrated, and there is also automated machine learning and stuff like that. So MLflow essentially helps you keep the track of your machine learning experiments, whether it's a model, whether it's data, whether it's all the installation, pre-installation, post-installation code. If you want to ingest the model, you get all the data prepared, all the code prepared. And also it helps you keep the track how the model is doing. You get sort of unified view of matrices for defining which model it performs better. You can also put everything in your tracking server where you can see in which stage a particular model is, whether it's in stage of testing, in stage of production, whether it's archived. So in a sense, data scientists, this is something for you for much better either integration with the notebooks, or much better having overview of your models. Again, a beautiful view of what MLflow is. It has a tracking server which basically keeps track of your parameters, metrics, artifacts, metadata, and models. And then once you register the model, you can basically just have it pushed through different stages, whether it's, you're experimenting with the data. Once you decide that it's working fine, you push it in the stage, and then you collaborate with different deployment engineers or business people saying, okay, now I'm totally, satisfied with this model, performance of the model, and you push it into production. So all this is actually part of the Databricks, and Databricks actually gives you not only, getting the data, doing ETL, and then doing some analytics, but much more. Also, storing your models, code repositories, version controls, basically everything. Koalas, as I mentioned, is something that was introduced in 2019, and it was a response of the community because people were not fond of writing Spark code. And of course, Python becoming more and more important in data science community, people are very much fond of these pandas. So pandas makes you, do all these data transformation, data preparation tasks fairly easy, whereas Spark, you can see on the left-hand side, pandas versus right-hand side Spark, makes it, in a way, harder to read. So what they did was, they said, okay, we're going to create an API on top of Apache Spark, and we're going to imitate the pandas, and we're going to call it koalas, of course, since we are in this animal kingdom. And if you look the code, koalas versus pandas, you can see that they are fairly the same. So with no hassle, with nothing much more to do, you can now use koalas. In terms of the performance-wise, Koala should be much faster because it's native in terms of reading the direct APIs from Apache Spark, whereas the pandas, you do some sort of much more transformation of the data on top of the Apache Spark. So this was, again, something that, data science community was very fond of the new package. Coming to Lakehouse architecture, there is a URL to this article at the bottom. And the idea is that we have seen this data warehouses. So I'm going now from left to right. So first generation, current two-tier, and the Lakehouse concept. And the idea was that, we all have issues coming to data warehouse. Why? Because it takes time to get the data. You have to refresh all the dimensions, you have to refresh all the cubes, fact tables, and it just takes time. So this was, back then when we had less data, et cetera, et cetera. So current two-tier is basically two types of tiers where you have the data lake at the bottom, and you have some type of ETL that directly pushes data to data warehouses. Or you can have data scientists or data engineers go down directly to data lake and get some, immediate structured, semi-structured data. Now we are coming in a phase where Lakehouse platforms are being introduced, and this is something that Databricks SQL is sort of grasping around. Is that the idea is that we can have open direct access to any type of data formats. It can be Apache Parquet, it can be Delta Lake, and basically with that we can have data directly fed into Power BI report, into data science project or machine learning project. So without any type of waiting and stuff like that, we can do that. Of course, there are some caveats, and this is the metadata, the caching, and the indexing layer. So how does this actually work? So you have so-called metadata layer for data management, and those are basically taking care. You are getting data cached. You have so-called auxiliary data. It can be any type of indexes. It can be any type of metadata data that will describe the way how to get data to your set of data faster, and also the data layout, which can be understood as a, let's say, schema. And on top of that, everything was built in terms of C++ code on top of Delta engine. So Delta Lake is the one that will either in batch or in stream get the data relatively quick, and it will give you much better performance results. So this is basically how they've engineered this concept in a way that you just define the endpoint, you connect through that endpoint to any type of data. It can be a CSV file in blob storage, it can be SQL database, it can be Parquet file, it can be HDFS, DBFS, basically anything. And on top of that, you then are grasping the data. In theory works, but to get the actual results, you would have to have some additional heavy duty testing executed. Anyway, so this is the Lakehouse architecture that was kind of introduced, and the Databricks SQL is part of that. So what is Databricks SQL? It is built on Lakehouse architecture. It is fairly simple to use. You can store and you can basically manage all of your data. It offers any scalable and optimized SQL workloads. No problem whatsoever about ACID transactions. Supports multiple concurrent users. So for those who are coming from larger enterprises, there shouldn't be any problem with that. You have a beautiful visualization, data browsers and stuff like that. And of course you have endpoints where you can, either get data to Power BI, Tableau, or you can, expose it as an API. All those workloads in this area here, they also have the endpoints, and those endpoints can also have compute power. So basically you are giving quite a lot of new compute power to different endpoints. And you can say, okay, since this is a report that it's, I don't know, aggregated once a week, I'm just going to give you a small amount or small chunk of virtual machine that will, do whatever needs to be done. If you're having some heavy load, you can have, sort of like a huge compute cluster that will manage all the workloads. In essence, what it does, it has compute power decoupled from storage, and it has this metadata layer that resolves caching, indexing, takes auxiliary data structure, and it can operate through any of the clusters in Databricks and Runtime, and also communicates with the endpoint, which is again another virtual machine. Okay. So yeah, this is the demos for today. If you want to, ask, just go ahead. So what I wanted to do is take a couple of minutes and just go through what has basically been upgraded, the Git, the runtimes. Then I want to just dive into data science or machine learning, how to do it, what is new, what's supported. And then for the data integration, we can look into Delta Lake, but I just don't want to bother you with, a lot of Spark code. What is new with data integration is they've introduced the orchestration, which is similar to, for those who are using Airflow. So Apache Airflow is sort of integrated here, not sort of, but it resembles. And you can then orchestrate your notebooks, your Java zip files or jar files, and also code. So previously, for those who were working heavily with Databricks, the problem was that once you have your notebooks created, you wanted to orchestrate them, it was quite cumbersome. Now you have this orchestration, like Yarn and everything, and basically those orchestration services navigates through jobs what's basically happening. So a beautiful upgrade, I have to say. And then Databricks SQL. So the first part would be just a brief overview what's new, how these workspaces have been created, and the runtimes. So I'm just going to go to my Databricks and we'll just start from scratch. Okay, so first of all, if you are new or if you want to get, so these are those workspaces. You will see that I will be using also the premium pricing tier because Databricks SQL is currently in preview. So if you're not using your premium pricing tier, you will only see the data science engineering workspace and machine learning workspace. So I have a couple of different, so this is my premium. And if I launch it, you will see that I will get also the additional tab. So, so I have the data science, engineering, machine learning, and SQL. So this is something to remember, have premium tier enabled, and then on top of that, you can start your stuff. So what's new? So first of all, you can see that Outlook is fairly new, changed. All the settings is it's on here at the bottom. So, and every time you switch between those workspaces, you can see that you will have different set of the items here. So now I'll go to machine learning, and you can see that I get some additional. So I get some experiments, feature store and models, and of course repos. And if I go to SQL, I'll have a completely different view. So these are the so-called workspaces. What's also new, prior to this upgrade, you couldn't have your repositories integrated. So now what you can do is just you go to Git. Of course, you have to log in, you have to add the repository, you can clone it, you can make a request, you can pull it, it's really up to you. So in this case, I am connected to my personal GitHub repository, and I can either clone or I can just sync it and then push all the workload there. So it's fairly simple, and you can also get a couple of different GitHub providers, Git providers. I've tested Azure DevOps and I've tested GitHub. So the other one I haven't. You can also do the branching, and it's, so far a marvelous upgrade. What is also new is, so if you go to compute, now they've basically, if you go to create new cluster, you will see that what they've done is they've sort of decoupled those runtimes. Now you have standardized and machine learning. So standardized would mean that you get your, particular data engineering runtimes with, sets of predefined virtual machines and stuff like that. You still have long-time support, extended support, and different versions of Scala and Python. If you go to machine learning, you will see that you also have LTS and extended support, but also some GPU and stuff like that. So all these ML runtimes, they will come with additional packages or Python R Scala packages pre-installed versus the standard one that will just be, bare bone in this manner. Now also you have this DBU, sort of just to give you an idea how much money you're going to spend. Otherwise, this part is relatively the same. And also Spark 3.0 is, fully on board. For those who are using all the version of Spark, there are still 2.4 supported, but, feel, you should start feeling the need that sometimes they will deprecate this runtime, and you will just need to upgrade to 3 point. Those extended ML support or extended standard, usually LTS takes a year to have support. Extended support means additional year or 2 years. Not really sure. Go to Databricks documentation to figure that out if you are in this zone of using those supports. Also, as I mentioned, the rest is literally the same. Okay. So this is fairly just breaking the ice type of demo. The second one would be automated machine learning. It's still in public preview. Model prediction and MLflow. MLflow has been here for quite a while, but the first AutoML and model predictions is something new, relatively new in the past year. Okay, so what I need to do is I have to go, instead of the workspace data science engineering, I have to go to machine learning. All the notebooks in this, switching between those workspaces remain the same. So you can see these are my notebooks in this workspace. If I switch to different, I still get access to all those notebooks, all the data. So this basically doesn't change. It's just, for the clarity and user interface, this is basically that you get some additional items. Okay, so what is new? So once you start your experiment, you go to experiment and you can now start automated machine learning. So this is something which is fairly similar to automated machine learning with Python in Azure. So fairly similar, and it's really nothing that much. You just select compute power, type of the machine learning problem, dataset, etc., and then just say, okay, after 2 hours, finish, you go out for dinner or something, and you come back and the results will be waiting for you. So in this case, you have to have Databricks runtime. If you're using this, it says here that you have to have machine learning 8.3 or above because of additional packages and additional cores that are needed in this case. Once you have that, you select type of the problem, and you can see that forecasting is only available in runtime 10 or above. So once you have that, you browse for the data. Just simply click that. You browse, whether it's table, a file, doesn't really matter. You select something, and then you define the prediction. So I'm just going to go and just for the sake of this demo, and you give the experiment name and the prediction target. There should okay. You define what are you trying to predict. So in this case, I can say I want to predict the funded amount, and I'm going to go with regression, like that, and that's it. So give your experiment a name. You can also configure some additional parameters like stopping condition, number of trial runs, and that's it. And once you do that, you just, as I said, you run it, you leave it running, and that's it. So let's just keep that and presume that I've had it running now for an hour or so. So this is a simple sample data set. And once this is completed, you can see that all those models, the results are using different type of the algorithms. So in this case, data would be trying to predict the breast cancer. And you can see that, these are different runtimes with different configurations, but all the metrics are basically unified, so you can see which model was performing better. And also you can get much better overview on the classifier and estimator. So these are all those important things that you want to use once you either decide in which direction you want to explore your prediction model further on. The best part is that you can either view the notebook for the best model, and you basically click it, and you will get a new environment with predefined notebook. So this is something that I haven't written, so this comes predefined. What you need to do is just attach this notebook to a cluster, and you can just let it go. And it will basically give you an explanation of why this model is predicting the way it is predicting. And you can see you are using one-hot encoding, feature standardization, validation, and then classification of this particular model. You get beautiful representation, and all those classifiers, everything is literally written here for you. The best part, of course, is, as you can see here, all this is also added to MLflow. Why? Because once you start doing that, this will automatically register this particular model, prediction model, into MLflow. So how do you know when this has happened? Okay. So remember, I was here on the experiments, and you will see that models here, this one has been registered. So all the models are registered right here. So this one I've registered and then just played with the model itself. So you can get the best model. You can also get the exploration notebook, which means that, you can explore, trying to understand some additional parameters, the data, et cetera, et cetera. And once you decide which model you want to register, this model will be available for you basically right here. So I've now clicked on this model. You can see it basically just takes me right here, and you get some additional descriptions. You can add some tags. You can see the input. You can see the output, and you can start then putting this model in registry or in MLflow, and then you can see how your model is then going through different stages towards the production stage. So you can see that I've created this model and push it to staging, and then from staging to production. And this can be part of many users working on that, or users from different departments deciding which model would be the best model for you. So again, this is actually the final overview, and this is my model. So you can see that the first version was created, and now it's in production and it's ready to be consumed. So this is something that basically is new. So automated machine learning is new. Model view or MLflow with this tracking server, this is something that has been around for at least 2 years, I have to say. But I find it very beautiful, and it's really not that hard to implement. The only thing you need to do is, let me just find that notebook. The only thing you need to do is to register the runtime once you start working on the model. So you can see that it comes predefined in this notebook, and it says I'm gonna just put this model in tracking for you, so you know what's going on then with this particular model. So if you're starting with a data set and you don't know which type of the algorithm you want to choose, how good my model was performing, what you can do is you can simply just go into machine learning workspace, create a new automated machine learning, decide on the best model, and put it in MLflow, and then start consuming the model. So this is something which is fairly straightforward and fairly beautifully used. And I think that this part of the demo is so far concluded. Okay, I'm just gonna switch back to the slides. So yeah, we've touched basically all of those areas. So this one, for those who are data engineers, and the reason why I'm bringing this up is, data engineering is also part of data science. It's not just, I'm just going to grab some data and then, start working on that. Sometimes there's a lot of pre-processing to be done, cleaning the data, preparing the data, matching the data, deduplicating, all those yucky stuff that needs to be done with the data, but still, it has to be done and somebody has to do it. So in this case, what you have to do is you just go to, once you create this, you can sort of orchestrate all those tasks now using this Databricks job. So what you're going to do is you're going to go to data science engineering, and you're going to go to job, and in job you will see that you will have under the tasks, you will see that you can then sort of bring multiple notebooks or jar files into this process. So beforehand, what you had to do was you could create a simple job. So you would say, okay, I'm going to create a job and I'm going to, bring a notebook to that job and, just have it scheduled and rerun, based on schedule. Now you have these tasks available. And these tasks will basically bring you the capability of orchestrating many different notebooks. Beforehand, you could do that using Azure Data Factories. You can also use this with sort of, running a notebook and then chaining it to another notebook and chaining it to another notebook with input and output parameters. But in my personal opinion, this was really, tedious work. So yeah, usually ADFS was the best solution. Now, you can do everything natively here. So how you would go about, you just create a task, you say, okay, run this file or do something with this file, get this cluster, and depend on whether it's a starting task or the ending task, says, yeah, once you finish, go to next step. So depends on, and you defined it. So this is basically a flow, and you can then orchestrate, which means that you can have multiple different notebooks run simultaneously on the same cluster or different clusters or pool of clusters, which basically gives you a huge amount of compute power, especially if you have, really some small tasks that can be done fairly easy. You can take, a small cluster or even bigger high performance clusters. You can also basically do that. So it is fairly beefy, pumped up type of this data orchestration. And what's also new in this way is, okay, I'm just going to run this. It's delta tables. So, and the next part of the demo will basically be focusing on this data set. So I'm just going to run this and then start explaining what I'm going to do. So I'm going to run the cluster. So in this case, what I'm doing is I'm creating a database if it's not been created beforehand. And what I'm doing is I'm actually importing the data. Let's presume that there are some data coming in my file store. So it can be HDFS, Databricks file system, and it can be CSV files. It can be anything. So this chunk of notebook, what it's doing is actually trying to figure out the schema, getting the data from the stream and then aggregating it into a Parquet file. So this is something that is done now much better, much greater needed improvement has been done here. So delta tables now, for those who are dealing with a lot of streaming in data, this is now done extremely beautiful and it works flawlessly. So just let me wait for the cluster to start. So essentially what this will do is it will simulate the Delta Lake and putting it into Parquet files as a part of two streams. And you will see right down here when it comes to this part, how the data will be ingested. So then I will just leave that for a couple of minutes, we can go to the next demo, and you will see in Databricks SQL that all these files, all these basically rows or all this data will be visible and shown there. So the next demo would be then to jump into Databricks SQL, and this will be probably the last. This is the last demo, and I just want to take some time and get some comfortable with this part, because this is something that, in my opinion, will definitely be a sway away from notebooks into people that are more comfortable with writing SQL queries and trying to understand the data. So what I'm going to do now is I'm going to go back to here. Okay, so this cluster is now operating, and I'm just gonna go and run it. So yeah, and I'm just going to leave it here, and that's it. So once you click on this SQL, you get to a new workspace, which is called Databricks SQL. And this is composed of dashboard, queries, data, endpoints, and of course, some alerts and query history. So this is, again, in preview, something new, in my personal opinion, very useful. So where would you go about? So you can start, creating notebooks from scratch. You can start writing queries from scratch. But first of all, what you need to do is you need to get some data. So how to get some data and how to set up an endpoint. So an endpoint would be a cluster particularly working on that endpoint. So once you start writing a query and then you hit run, this is actually the endpoint, and this machine will then take care to get the results back to you. So once you have the endpoint, so this is fairly simple. You just create an endpoint and say type of the cluster, and you have the DBUs here, and that's it. So I have Photon. It's by default enabled, so that's awesome. What you need to do next is you need to create a table. So by default, you will have some samples or Hive metastore, I don't know, and you can either import the data. So this is something that I've imported from my COVID notebook. And how did I import that is simply by using Spark. So I'm just gonna go try to find this is gonna be interesting because I don't know where. Okay, first of all, I need to find the right environment. Okay, I think this one will also work. So what you need to do is you basically need to either write some Scala down to container SAS and sort of get the data. In this case, what I'm doing is I'm getting the data from Azure Data Store, bringing it to Databricks. So you've created your container. So remember, you go to your storage browser, you get all the needed information, whether it's a blob container, file share, tables, whatever, and you can bring that to here. Once you have this registered, it will automatically put that into your Databricks cluster. Databricks cluster then will have this data available in form of database table or DBFS. So you can see that all these tables or data are available here. So I am, in this case, so I'm just going to put this a little bit closer so I don't get confused. What I'm looking right here is default and delta DB. So this is my metastore, and this is basically the same representation of those two tables that are available here. What I've done in addition is I've imported this dataset using Scala, and I've also imported I've also imported this dim country in a form of create table. So this is something, and you can have different type of the data bringing in. So first of all, you need to create these endpoints. Where are you getting the data? So it can be, different Hive store. It can be Azure Blob Storage. It can be Elasticsearch. It can be Cassandra. It can be SQL, all those stuff is basically available, and you just need to register it. And once you have this, you can start writing a simple query. So first of all, how you write a simple query. So this is basically what you are looking now is a editor, and in this editor, basically you are writing your simple queries. It's not Transact SQL, but it's ANSI standard SQL. So you can create function, you can create tables, you can insert to the tables, you can create simple joins. You can also create tables and with a pointer directly to a particular location. So, all those SQL operations are here. Even if you want to do some delta functions, delta lake, you can also do that using the SQL. So basically, you are covered in terms of stream or batch from the delta lake. Once you have your query or many of the queries created, and you can see that I've created some of them, and those are fairly simple. So in this case, what I'm going to do is I'm just going to run this query that says, go to this database in this table and do something, execute this operation. Once I have this created, I can start creating a dashboard. So dashboard would be something like that. It can be, anything. It can be much more beautiful. It can be iterated. It can be etc. etc. Really doesn't matter. So you are basically constructing these dashboards from different parts of SQL statements, and you can schedule it to refresh. You can share it. You can expose it, stuff like that. So now that we are reading this data, and these are SQL statements on top of delta tables. So this is the delta table that I was running previously, and you can see that this stream is basically coming in real time. So these are some fake data coming in, and you can see that the batches are literally those that are, these are the timestamps UTC, and you can see that these data are coming in. So now I can refresh this, and you will see that these numbers will literally change. So this is the gist of this Lakehouse, that you can either grab the data from data warehouse, or you can grab the data from Delta Lake, or from CSV files, or from blob storage. Anything goes. And this is basically getting the data literally in real time. So you can see that since the data is pumping in, I'm getting different results every second. So I've also created another dashboard. So this one has some, it has just one parameter. So all these queries can also be parameterized, which means that on the same data set, now what I want to do is I want to see, based on either time or some filters, what is the result. So I can now say, okay, I don't want this country. I want to select, I don't know, where's the famous country, and all the data will be changed on the fly. So in this case, what happens is I'm basically selecting this, and there are like 1, 2, 3, 4 SQL statements running on the same endpoint, or it can be on different endpoint, really depends on how I want to have those created. And those endpoints can point to a different data source. It can be Delta Lake, it can be, as I said, DBFS, it can be a blob store, doesn't really matter. And those will then come together in a form of a beautiful dashboard. You can also create alerts. So this is something that just fairly simple. If you want to do some quality checks on particular data sets, say, okay, once this particular number goes beyond that, or this particular dimension metric goes beyond the particular threshold, just send me an email or create alert or whatever. So this is something that you should keep in mind. So I've created a lot of queries. Those queries are fairly simple. So you can see that, some counts or some, I don't know, some joins probably also. And also same as in Databricks notebooks, you get the results. You can say, okay, I want to have my results represented in table, or I want to have some additional visualization added. And you will have all the visualizations available right here. So you can see counter, you can see this, you can see the table, and then you decide which one you want to sort of give to a dashboard. The beautiful part also, which kind of reminds me of Snowflake, is that you also have all the query history, which means that everything that will be run will have a unique ID attached, and you can see on this particular query execution details. So this is something, if you want to troubleshoot or see who's doing what, you can also use that as well. And this is, how would you basically go about? You can also create an endpoint and connect it to Power BI. You just need to have a premium Power BI with a premium account, and you can get the data directly as well. And this is, how Databricks envisioned these workspaces, sort of like a unified platform. So you would have your data engineer, data scientists working in this workspace, machine learning people, those who are deep in, let's say, algorithms, and DBAs or SQL or analysts or BI people that can work with SQL. So they all come together. The question I still have is how to get Python data in here. Well, you can't. How to get the results of a particular pickled model in here? Well, you can't. So in this case, in such scenarios, what you need to do is, of course, you need to have, for instance, you still need to have your machine learning notebooks created and have all the data basically popped here. So in this case, if I want to do, let's say, those COVID cases that I've imported in Databricks SQL, in this case, if I want to do some more machine learning stuff, I still need to do it here. But the beautiful part of these notebooks is that I can easily switch between languages. So with percentage sign and SQL, I can just start writing directly on this data frame. I can start writing select statements. So this is, again, something worth remembering. And also the not so okay part is also that these queries are not in any way versionized. They're not in any Git. So this is also there are a couple of caveats here that you need to be considerate of. But otherwise, having SQL on top of all the data in Databricks, this is truly amazing. So this was the last demo. Thanks for your attention. I think we finished on time. Again, if you want to have the material for this session, just follow this link.
So, okay, Tomaž, so given what you just showed us with what I believe was the redash functionality of Databricks, all the beautiful charts. So this question basically is as follows. Do you have any personal opinion on choosing Databricks SQL over Azure Synapse Serverless?
With Databricks, everything is much faster in terms of setting up the environment, going to an enterprise environment. And with all these additional runtimes, with these new workspaces, with this decoupling of the compute, with SQL, with this Lakehouse architecture, and also improved Delta Lake, I would definitely, be hard to persuade to switch to Synapse. I'm not saying that Synapse is bad, not that, but Synapse is more, a lot of data warehouse, all this stuff, whereas Databricks, in my personal opinion, is more lightweight, and it can be used either as a ETL tool, orchestration tool, machine learning tool, data science tool, analytics tool. So for those tasks, analytical tasks, I would definitely choose Databricks.
So considering that, can the Databricks, and especially the Databricks SQL, link to a real SQL server or a Synapse or an on-premises server?
I'm going to say yes with notebooks. I don't know with Databricks SQL. So with notebooks, I've done that. With Databricks SQL, I have to say I would need to check. I don't want to, say anything wrong, so I would need to check.
Right. Mikhail, do you want to do that next one, or do you want to skip the next one?
So when you set up a cluster, we got an estimation about what it costs to keep running. And that cost, is that the cost the same when you're training your model and making it go crazy as when you're doing predictions or when you're just sitting there and do nothing in your cluster?
So you are basically getting billed for the compute power. So there will be less of a cost if a cluster is idle, and more cost if there would be something really going on. So, but essentially, once the cluster is running, you are basically getting built. So yes.
So next question might be a bit unfair if you haven't used Azure DevOps, but the question is, how does MLflow fit with Azure DevOps? Does one replace the other, or should we use them together?
That's a good question. The MLflow has this tracking server, which DevOps, I'm going to say I haven't seen in DevOps. So in Azure DevOps, you don't have this tracking server in terms of what's going on with your model, how your model is performing. So DevOps is very sort of common for any type of file. It can be, any code or anything. Whereas MLflow will also give you, once you decide, yeah, I want to put this in production, I want to download the artifact, I want to get the code, I want to get the matrix. This is something in addition that DevOps, from my knowledge, does not have.
So to clarify, is MLflow is kind of more tightly integrated then into the machine learning lifecycle, is
Yes.
it? Okay.
Yes, and MLflow, as I said, is an open source, so there is really no need. You can also get Databricks Connect and use MLflow with that. So you can either write Scala, or you can also go through CLI and start using MLflow. So it's really, I wanted to say agnostic, but in a way you can basically use it from different platforms, different languages. But it is specified for machine learning models, artifacts, and stuff like that. So in that sense, it's much more narrower in terms of use, but it gives you, for this particular tasks, much more than a DevOps.
Okay, cool.
It seems like you already answered the next question almost, because it is about, can you run the model code or the model algorithm you get out from this automated machine learning in or from another environment in Azure? For instance, call it from Stream Analytics or another execution environment.
Okay, I'm taking that yes back. So I've shown, once you decide for a particular model, you get all the code, and this code is actually, it can be Python. And if you have any other ways where you can run this Python code, then the answer is yes. Stream Analytics, if it supports Python, I would go with yes. I know that I can download the model pickled version from Databricks and import it into automated machine learning with Python in Azure. Or I can just download it and use it on my, personal local Conda environment. So it's sort of, like Onyx or PMML, you just grab it and you can use it basically anywhere.
A real practical question from Fry. How would you publish or grant an end user access to a dashboard outside of Databricks? So how do you share your wonderful work?
So like this. So you put all the users, the admins, and tell, how you want to do it. And, if somebody would be registered, and then they can see it. Outside, not really sure if it's possible.
So they have to have an account in your Databricks environment, but it can be a normal user.
Yes. So the viewer or the owner, and then different credentials. So everything you want to do, you have to have either Active Directory credentials. Once you're in, you just go in and start working on that. So that's it. Outside, that I don't know if there is any code that you can expose this. I know that Power BI uses natively Azure Databricks connector, and you can connect to different data sources, DBFS, and then expose those in Power BI. This can be done for this particular dashboard only within Databricks. By the way, this is done in in Plotly. So if you hover over, you can see that you get all these Plotly consoles. You can download it as a PDF. This is the only version, and you get a PDF, but not really sure if this is something worth mentioning.
Okay, so we go to the final question of the evening. You did kind of cover this, but probably worth just elaborating, I guess. So Taha has asked the question, how are the dashboards created? Is it a similar experience to Power BI with drag and drop feeling?
Okay. So let's consider this is my dashboard. I click here on ellipsis. I go edit and click add visualization. Prior to that, I have to have my query prepared. So query would be an element that will return a result. So let's say that I'm just going to reuse this one. Not really sure what it is. And add it to dashboard. And then it gets added to dashboard. I can resize it. I can, rename it and stuff like that. I'm pretty sure that they will definitely work on that and come up with, some additional editing and stuff like that. But this is for now. And then I can view the query or edit it, and also recreate how I want to see it. So currently it's set as a table, but if I want it to be as a chart, I want to save it, and then it will pop up in my dashboard as a chart. So this is how would you go about. So create a query. So create a get the data, create an endpoint, create a query, and start coming with this dashboard, creating this dashboard.
Great stuff.
Perfect. So that would conclude the questions, and a big thanks for joining us today, and a very big thanks to Tomaž for sharing.
Thanks for having me, and you were a beautiful crowd, even though I haven't seen you or haven't heard you. And stay healthy, and wish you all the best.